Folks, welcome back. I had something totally different planned to shoot today, but then I got up this morning and I saw this comment from a fellow by the name of Olawayne. I hope I'm pronouncing that right. There's an exclamation point. Who I felt deserved more than a one-sentence YouTube comment response. So let's get after this. Olawayne says, "Hey, great video. Helped me already a lot and learned so much. The idea with the safety pin is amazing, but what was the paste that you put on the capacitor to solder it off and why?" Well, what he's referring to is this stuff right here, which is called Flux. And what it does is basically three things. One, it removes oxidation from the solder that you're working on. So if the board has been assembled for a while, you get a little bit of oxidation on the outside of the solder joints. And this stuff helps remove that oxidation so that you've got clean solder that you're working with. It also helps prevent new oxidation from forming while the solder is molten. And finally, the most important function is that it helps the solder flow more freely. So you get nice little pools of solder on the pads that you're working on, as opposed to these horrible globs that make it really hard to solder stuff to. All right, so here we go with no flux. And if we stick the solder on there, we'll see we get this sort of nasty, dull... Vector does not approve of soldering with no flux. See how you get these little tails? And the solder just kind of makes gross globs. That's with no flux. If we grab the flux, I'll put just a little bit of it on there. And now we heat this end of the capacitor. May need a little extra solder here. Doop. See how quickly that works? And if we turn that, you see how it's nice and round and shiny? It's got a lot of solder on there because I resoldered an existing component. But you get the idea. Gross on this side, beautiful on that side. All right, Olawayne continues. I have the same problem as in this video. Brix completely dead, but the power button has power after plugging in the power supply. But nothing happens, no light, no fan when pressing it. I measured with my multimeter that the button pulls the value on the previous 3 volts to 0 volts when pressed, so I assume it's working correctly. What would have been your next steps if you wouldn't have found out the power is cut off by the safety transistor? I'm a bit lost right now. I think I can rule out any short circuits on the board now. Is this correct? Thanks for your help. Okay. First of all, no, that's not correct, unfortunately. What Olawayne is referring to as the safety transistor is this part of the board over here, which is called the inrush limiter. And what that does is prevent a ton of current from being passed through the input jack when you first plug it in with the other end plugged into the wall. So when you first plug that in, you've got 19 volts, and it's going to send a ton of current as it charges up all the capacitors and stuff on the board. And that's undesirable, so they have this circuitry here to help limit that. And in the case of this board, that was one of the things that had failed. Now, Olawayne says that he's pretty sure there's no short to ground on the board. And what I would do in response to him is ask, well, how do you know that? And the first step you probably want to do, once you've determined that you are getting power to some portion of the board, which you wouldn't be if the inrush limiter was burned out, is to measure the resistance to ground on each one of your voltage regulation modules, also called buck converters. Now, a buck converter consists of a transistor package like this, an inductor, which is this large kind of rectangular component, and some capacitors, along with some control logic, which in the case of these two guys over here is this right here. So we've got probably the CPU, and we've got a GPU rail. And I know because I've checked these that they're not connected, and it's not 2 phases. We've got a 1-phase CPU power rail and a 1-phase GPU power rail. Plus, if we look around the board, we've got some other inductors that are clearly separate rails. So we got this little guy right here, we got one there, we got another one here, and we got another one here. And I know because I've tested this one here is your 3.3 volts. So what we're going to do is, before we do anything else, with the board unplugged, we're going to test the resistance to ground on each of the outputs, and the choke can be thought of as the output from the VRM. And we're going to make sure that we have a sane, or the expected resistance, between the output of our choke and our ground plane, which is basically anywhere that you've got big exposed copper pads like this on the board. Or you can do the housings of these jacks and so forth. But I like to use these little screw holes because I can put the probe in it like that, and then I don't have to hold it. So, a choke is just a piece of wire wrapped up into a coil. So the resistance through it is very low, and we can measure either end of the choke as is convenient to measure the resistance to ground. The other end of the choke is connected to our transistor, which is, you can imagine that as just not connected to anything while the system is off, at least for this purpose. So, what we want to do is take a resistance measurement on the output of each one of our VRMs and see if we've got any that reads 0.0, which would indicate an actual short to ground. So, let's try this side over here. And we get 6 point something. Now that's a little low, but for a CPU, that's probably perfectly normal. In fact, on a bigger IC like a GPU, we sometimes even see less than 1 ohm. So like the latest NVIDIA 20 series GPUs, those typically have a resistance of like 300 milliohms, which is 0.3 ohms. So 6.6 on that rail is probably okay. Now we've got this guy here. We're going to check it. We've got 8.2. That's probably also okay. The biggest power rails on the board typically power the largest IC on the board, and a low resistance like that is perfectly normal. So currently we don't suspect anything wrong with those. Next we'll try this guy right here. And we've got 18 ohms. That might be a little low, but to be honest, I don't know what this powers. So that's possible, but unlikely to be a problem. So for the moment, we're going to say this rail is probably okay. No short there. Next is this one. I suspect this one here is the memory rail. And I say that because we've got 43 ohms, which is commonly what you see for the memory rail. It's higher resistance than the main logic, but not triple digits generally. Or sometimes you'll see like 150. At any rate, it should be modestly low, and that's looking okay. Then we've got two more. One of these is our 5-volt rail. Remember, we've got USB, so we're going to have 5 volts. And we've also got a 3.3 volt rail that tends to be used to power stuff like our controllers for our other logics. So the way that this would probably work is that you power up the 3.3 volt rail, and that supplies power to the controllers to power up everything else. So if this isn't working, nothing's going to work. So we'll try our 3.3 volt rail, and typically what you see on this is about 300. So we've got 266, 267. So that looks okay. And we'll check our, I suspect this is 5 volts. And we've got a few K. That's probably okay too. If nothing else, that is definitely not a short to ground. The next thing I would do is plug the board into power. And I'm not going to do that here because this board isn't in a state that it's safe to do that. And I would take a voltage measurement at each one of these positions. So you switch to voltage mode, and being careful not to touch anything else. Touch the output of each one of our chokes, and we're going to have 0 on all these because it's turned off. But you're going to expect about 1 volt on most of these. So 1 volt here, 1 volt here, 1 volt there, and like 1.5 on this one. If this is the memory rail, you're going to expect like 1.3, 1.4, 1.5, somewhere in that range. Then probably 5 volts on this one and 3 volts on that one. All right, so to answer Olawane's question, that is what I would do next. I would examine each one of my VRMs to make sure that I had the appropriate resistance with the system powered off and the appropriate voltage with the system powered on. And if either of those conditions is not met for each one of those voltage rails, then I would troubleshoot that circuit more thoroughly. Examine the controller, which for these two guys is right here. Examine If there's an enable pin, make sure that that's getting a signal. Examine the capacitors and make sure that one of them is not partially shorted. There's any number of things that can potentially go wrong with each one of those, and without knowing which one it is we're looking at, I can't really advise further. But what I would say to Oliwane is, try this test, check the resistance on each rail, and check for voltage, and respond in the comments with what you find, and maybe I can help you get further down the road with your diagnosis. Anyway, for those of you following along at home, I hope you found this interesting or helpful, and I'll see you in the next one.